Hello and welcome to Identity Office Hours. I'm your host, Mike Schwartz, founder of Glue. Today is episode 202. And before we get started, a quick reminder, please follow the live stream on LinkedIn or YouTube. The topic today is when identity isn't enough, securing AI agents at runtime. And our guest today, as many of you can see, is Roshan Sheikh. Roshan, welcome to the live stream.
Thank you, Mike. Happy to be here.
And before we dive into the actual topic today, it's traditional to find out a little bit about your background. How'd you get here?
Yeah, sure. I'm Roshan Sheikh. I've been in the cybersecurity industry for well over 25 years. I've been in engineering leadership roles at Cisco in the networking side, Silver Spring Networks doing machine-to-machine connected devices at scale, as well as at Equinix building their interconnection infrastructure and interconnection fabric. And recently, I was at Okta for 4.5 years doing the identity. So the reason why I founded Runtime AI is I kept seeing the same gap wherein every enterprise has to build their security stack, assembling various vendors, identity, security, network perimeter, runtime enforcement, auditing, logging, compliance. And we wanted to be a one platform, a security platform that does all of this, including identity, runtime enforcement, compliance, and your network perimeter, and that combines all of your AI security that the AI agents are doing today. So yeah, so you can't bolt all of the security on the top of existing tools. You need to build a AI native platform that understands the AI agents, their behavior, and enforces the policies as they are autonomously executing your workloads. So that's why I founded Runtime AI.
I feel like we end up talking about AI impact on our industry about 4 out of every 5 episodes. So we're happily back on track. Although I think the last episode we have had was also about AI. So it's very relevant to our industry. But I think I got interested in having this conversation because about a month ago, you posted something that resonated with me, which is you posted basically, you said, if you cannot answer these 3 questions right now, which vendors hold OAuth tokens to your data, when were they last rotated, and what's normal usage on each one, then your organization is basically waiting to get hacked. It's like before the hack, time. Um, but why do you think? I mean, that struck me as sort of a interesting position, and maybe we could start with just digging into the first of those. Um, if you want to understand which vendors hold OAuth tokens for your resources, what is that involved, and how does the product that you're building at Runtime AI, how does it actually accomplish that? Knowing all the tokens that agents can call for your internal services, I guess.
Yes, that's a great question. So, what we do is we do a discovery of your existing resources, including OAuth tokens, identities, as well as your software bombs, cryptography keys, and we surface them uh, to the SOC or through the tool. And in this question, like you have to know your inventory of who holds your OAuth tokens. Just this week, there was a breach at Clue, and that uh, involved breaching of data from Beyond Trust, LastPass, Sneak, and various companies that have access to Salesforce. So all like 10 different companies, and they are using Clue, and Clue has one OAuth token that talks to Salesforce data of all these companies. That
Mm.
one OAuth token was exposed, and the data from all these companies now is also exposed. So if you have inventory of all of your OAuth tokens, when they used and what is their normal behavior, uh, Clue could have done is create normal baseline behavior and one OAuth token per vendor, not for multiple vendors. So you don't have one OAuth token exposed and then all of your customers' data from Salesforce exfiltrated, right?
Right.
So there are various layers at which we can stop using runtime AI. One is through inventory, your OAuth token, what it has access to. Second is any agents or any of your existing workloads. They use ephemeral token from runtime AI. Even if they get breached, they get a token from runtime AI, which is not useful at all outside of runtime AI. They don't hold actual OAuth token or actual API key because runtime AI is in the execution path of all of these agents, your workloads, cloud workloads. At the runtime, we replace ephemeral tokens with actual OAuth token and then send the traffic to your actual destinations.
So what you're saying then is, let's use the Salesforce Clue case. So you're saying that um, if let's say the end customer, Acme Incorporated, is
Yes,
using Clue, and Clue, I guess, has one Salesforce token that has multiple of its tenants, and you're Acme, and but there all the data for Acme and the other companies is one Salesforce like database
data.
um, for Clue. And you're saying that runtime AI would help here because um, Acme would install runtime AI, which would, instead of giving access to that Clue token, it would do a token exchange and return you a runtime AI token. And
Yes,
now the agent is requesting access and presents that runtime AI token, and you could evaluate policy on it um, before you actually send the request downstream. And does the AI agent in this case not even have a know about Clue? All it knows about is you, runtime AI, and so it can then just route, or then how to send this request to Clue.
yes. So actually, in this case, Clue would be the customer, and they would use runtime AI. Acme Corp can also use runtime AI for other activities. In this case, Clue would be the one, and
Okay.
Clue would have policies that says, or even if without a policy, runtime AI during normal execution of the workload. It could be AI agent doing this work. It could be just normal any workloads that are like CRM workloads that are accessing your Salesforce data, and then we'd have created a baseline behavior of this agent, wherein the token is used at let's say maybe 1,000 read calls in 1 hour. But the
Mm,
moment you see like 1 million read calls in less than 2-3 minutes, that is totally abnormal behavior. That means somebody is exfiltrating your data outside, and we can stop it in less than a second as soon as we see that anomalous behavior. In this case, neither Clue nor Salesforce have tools, runtime tools, to stop this breach. So they could have stopped it at any time when you see a single token is being used to exfiltrate Beyond Trust, Sneak, and all of these companies' data. Yeah, initially that setup itself is wrong. You shouldn't be using one token for all
right,
customers. And secondly, you should also have a runtime behavior wherein you baseline the normal behavior. Any abnormal behavior, you either regulate the traffic or you stop it, analyze, and then reallow the traffic.
right. And so, without passing judgment, I guess on Salesforce and Clue, because a lot of this stuff was built before we had better architectures. So it's easy to say now that's a terrible architecture, but we had a guest, Alex Weinert from Semperis, formerly of Microsoft, and he made a funny point. He's like, nobody upgrades the old stuff. We only get new stuff. And so we basically have an application that still uses Kerberos because, or we still need Kerberos because some application written back in the 90s, like, uses Kerberos and it hasn't been upgraded. Um, it sounds like we can mitigate some of that perhaps by what you're saying is we can say, okay, we have this important resource, access to Salesforce, and
Yes,
we can't give access to that because it's too powerful, and
right.
so we need to attenuate the access to that resource. So instead of ever showing you that magical key,
Yes,
um, we're going to give you a new key, um, we're going to do a new give you a new token, and then before we actually call that allow you to access that resource, we're going to evaluate policies, and look at behavioral metrics and
yes,
decide whether we actually want to give you that access. um, so let me drill down a little bit on that. um, do you is there in fact a way to express policies, or are you simply looking for anomalous activity?
yes. We are doing both of them. You can define the policy. In the policy, you can define the risk score. So we define a score for every agent or every workload, um, whether the data it accessing is read only or write or delete or any data mutations. The risk goes up a little bit. The risk
Hmm.
is also dependent on the identity, the freshness of the identity. If an agent or if a script or a bot is it haven't accessed any resources in your company for like less than a month or more than a month, the risk score goes up. So you can define how the runtime behavior should be based on the risk score. You can say if it's greater, it's 0 to 100 usually. And if it's greater than 80, you can always include a human in the loop, or you can stop those agents from accessing until the freshness of that identity is refreshed. And secondly, yes, data access. And third is the actual behavior anomaly. So based on all of these, you can have policies uh, that determine the runtime behavior. You can also define a policy for conditional access. So even if you give a read access or write access, you can say do not allow read or write access outside of the business hours or during the weekends. So you can
Hmm.
say if your GitHub Actions, CI/CD workloads, they are using these OAuth tokens, they're deploying it to your cloud, Azure, or anything. You can say do not deploy after hours because if something goes bad, there are not many people who can fix the things. So they have all of your identity, perfect logins, perfect company IP addresses, right? Do not allow egress policies where somebody can create a brand new S3 bucket and put all of your API tokens over there. Stop that. So there are many policies. This is like a programming for your security, AI security. You can program however you want, how deep you want, and then you can push these policies to the data plane where the actual policies are in line to the execution of the agents.
Um, and how are the policies expressed? Have you looked at standard policy syntaxes like Cedar or, I guess, Cell or other policy syntaxes? Like, or is there some other
Two
way that
ways.
you
Yeah,
express policy?
there are two ways. One is we have a natural English parser, so you can express them in natural English. Uh,
Uh-huh.
in behind the scenes, we use OPA, Open Policy Agents, and the language is Rego, so you
Uh,
can express them in Rego. But most of our customers use natural language. So in the natural language, you can say my customer support agent should not spend more than $1,000 per day in inference costs. So that we translate into a Rego policy and deploy it on our policy enforcement points, whether it's on the laptops or in your cloud or Kubernetes clusters, and we keep track of a ledger, how much inference costs your agents are spending. The moment it goes to 90%, we notify a human, and the moment it reaches the actual amount, we stop those agents doing any other actions. So this is just an example.
Hmm. Um, and it's an interesting perspective because you're sort of collecting, or you say inventorying OAuth tokens.
Yes.
Um, how many issuers would you say companies typically trust? Like how many OAuth tokens are they, um, or how many issuers, different issuers, are they collecting these tokens from?
So it depends. So many times your like deployment engineers, they create these tokens, give it to various clouds and completely forget about it. They'll have one offline scripts during an upgrade, and they'll create this token and they're completely forgotten. Come 6 months after that, somebody gets access to this token. They're still live, they're valid, they have full permissions, and breaches happen. Things go bad after that. So once you inventory these, and then you can renew or rotate these at one place using Runtime AI. And also, as I mentioned, there's a risk. So if the tokens have not been used for a certain amount of time, your risk has gone up. And the moment people start using those tokens again, they will be disallowed to use if you're using Runtime AI.
You mentioned the how long that token's been alive as like just a very good indicator for how dangerous it is or how risky it is. Um,
Yes.
and what are some of the other metrics you look at so that it sounds like what you have is a governance platform, right?
Yes.
Like when you govern, you enumerate something and you evaluate the risks, and then you make decisions based on those risks.
Yes.
So and I think of governance like steering, um, and so you're steering the traffic. Is this traffic that I want to allow to get through or not?
Ex-
Um,
exactly. Yeah. So that is just one level. We have various other machine learning algorithms to detect the traffic behavior. For example, you can have a token that is doing, you create some thresholds, and the AI right now, AI attacking agents, they will live below those thresholds, but they will still breach the data that you're allowing. So we look
mhm.
at a holistic enterprise account and see if there are any abnormal behaviors across the tokens, across the accounts, to detect if there's a breach happening and stop those behavior. We also look at your sequencing of API calls or LLMs. So in this case, you could be like doing read, and then write, or delete. So if you are doing certain sequencing, it suggests that the pattern is a data breach pattern, and we can detect that. We can notify a human, or we can stop that if there is a policy to stop that behavior.
Hmm. Um, so in typical fashion, we're like 20 minutes in, and we've only done point one. So
Yeah.
um, okay, so we talked about the OAuth tokens. We did talk about rotation. So let me expand a little bit because I said you're you're building a governance platform in a way, but it also is an observability platform too. It
Yeah.
seems, um, and what you're making visible is sort of the usage of these tokens.
Yeah.
Um, and um, when you say, when you inventory something, you need a primary key. Um, so a lot of modern identity has been, or ITDR, identity threat detection and response.
Yeah.
They use the identity of the username as the primary key.
Yes.
If you're using tokens as the primary key, I wonder what identifier are you using to store that? Because tokens have a JTI claim, which would be the unique identifier of that token. But so many issuers out there don't actually give you a JTI claim.
Yes.
And are you also saying that a token could just be a reference token, like a string? And so I'm wondering, the idea of inventorying the tokens, I have never really heard that approach before. Um, it's a somewhat novel approach, but I'm wondering, how do you even identify the token primary key so you can inventory it, or where do you store it?
Yeah, so this is for existing installations where OAuth is primarily used. We inventory that, but we inventory your AI agents as well, and we create identity for your AI agents or service bots. So this identity includes a X509 private public key certification. So you have MTLS. Every request has to be, encrypted, decrypted. OAuth tokens is only when you're accessing something outside of your
API.
application, right? So yeah, so that is your access, but your agent to runtime AI, there is a identity bound to a PKI. There's also agent to agent communication. So there's various other things that are happening at the agentic level. What is your resource access? It could
Ah,
be an API access. It could be your LLM access. LLM access is through an API key. Anthropic has an API key, for example. OpenAI has an API key. So
hmm,
those keys we also inventory. Like we scan entire all of your enterprise for AI. The scope of AI, where it's being used, what LLMs are being used, what API keys are in use, because we are in your network path, we are in your Kubernetes path, we are on your laptops where employees are using coding agents, and we can collect from all of this, give you the inventory, and then you decide, okay, I allow OpenAI and Anthropic in my organization. I do not allow DeepSeek. How do I block it? In one place, you come to Runtime AI, you block api.deepseek.com. All of the surfaces where your AI is using DeepSeek, it will be blocked immediately. So this is just like entire
okay.
scope of landscape I'm giving you. OAuth is only where an existing enterprises are using OAuth to access certain resources. But
I think I misunderstood,
yes,
but I think I understand better now. So you're not inventorying the tokens for as a unit of governance. You are inventorying the agents
yes,
and governing the agents. And you can be on the laptop because the agent might be running on that laptop and you've issued identities and you issued credentials to that agent running on the laptop.
yes,
So your strategy then is really your governance strategy, I should say, is to inventory the agents and then manage what the agents are allowed to do. And what they might be allowed to do is use one of those tokens that you've also
exactly.
inventoried.
Yes.
Okay.
So we are an entire platform. We secure your agentic environment. We secure your memory, agent context. We secure your prompts from injection. We secure your API calls. We secure your API keys. We secure your OAuth tokens. And we also do audit logging compliance in the same platform. So you don't have to accumulate 15 different vendors to be compliant with NIST RMF or EU AI Act. Like
Right.
you have, like
One of
today,
the
you
parts of
have,
governance is connecting to compliance. So yeah, I agree. One question though I have, is there an 80-20 rule for agents? Like there's a lot of agent platforms out there. There's Cursor, there's Claude Code, Gemini. Um, I'm probably missing many. There's Salesforce, Agentforce, um, Microsoft Agent 365, Amazon is Bedrock, right? There's
Yeah.
all these agent platforms. Do you think there's an 80-20 rule where if you just address X number of like platforms, you're good enough, or is it really a battle to keep up with all the different agent platforms out there?
Yeah, that's a great question. So we are in the network infrastructure layer. So whether you use Agent for ServiceNow, Lovable, or any of these to build your agents, and then you are running your agents in production as an enterprise, or your developers in an enterprise are using coding agents to develop your tools. We
Mhm.
are in the path for all of these, and it doesn't really matter to us because all of these access certain resources, certain destinations. The destination could be an LLM, destination could be your enterprise internal API, CRM, finance, or anything, or the destination could be your MCP tools, MCP servers that access something else. And we, because we are destination, we are protecting the destinations, we are protecting your AI agents because we are in the middle path. So it doesn't matter where the agents are built at, what those agents are actually accessing. We can secure your agentic workloads because we are in the execution path. But
Right. When you say network, um, I think you actually mean more like your sort of being a man in the middle, because at the network layer we have TLS connections, and you
yeah,
can't really see anything on the network anymore except
we
encrypted.
do a MITM, man in the middle TLS, so we can decrypt the traffic and look at your like DLPs, PII data, anything, and we input, change the traffic to actual OAuth tokens, actual API tokens, and resend the traffic, like re-encrypt and send the traffic back. So
Right. So, but my agent has to be, so if I'm developing an agent um, on Agent Force, for example, on Salesforce, um, my agent wouldn't know, I wouldn't put in the direct address of the APIs or the MCP servers for Salesforce. I'd give it the runtime um, proxy, let's call it.
there are
Or,
two ways. Yes, you could do a runtime proxy, or at the network layer and the DNS layer inside your enterprise, you
mhm,
can use runtime AI as a proxy to those DNS destinations. And at that point, we can interject and look at the traffic and do a runtime enforcement. So you
I
don't
see.
really have to modify your agents, their destinations. We can do this at the network layer itself, but you can
Yeah,
also modify to use runtime AI as a proxy if you want to use tokens like ephemeral tokens. Don't give actual Salesforce tokens or any other destination tokens to your agents, because your agents, because of recent supply chain attacks, you could install something like late LLM or something, they can export all of your API tokens to somebody else.
So it sounds like what you're saying is that I'm a developer. I'm calling Claude Code using Anthropic.com URL, but the enterprise is saying for Anthropic.com we're going to return you our runtime AI proxy, and
Yes,
so you'll think you're talking to Anthropic, but you're actually not. So the developer is actually even unaware that there's a proxy in place.
yes, that
Um,
is how most of the gateways, VPN gateways inside your enterprise are currently operating. We are operating at the same layer, and we are looking at the traffic going out, traffic coming in, and interjecting for any anomalous behaviors, enabling runtime enforcement, policies, conditional access, identities, so we can secure all of your agentic AI.
yeah. So there's been a number of OAuth drafts and other standards proposing agents are as a first class entity with its
Yes.
own metadata and registration. flows. Are you following any of those? And do you see any of them as sort of leading in the area for what does an agent and what are the claims of an agent? What does an agent entity actually look like? And how do agents, what's the right way for agents to assert their identities? How should they get tokens, etc.?
Yes, so we are following existing standards and also upcoming standards, IETF standards, how you can express your agentic identity. So SPIFFE is already a standard that is used in all of your Kubernetes clusters.
Great, but just can I hit pause there?
Yes,
Spiffy just says how you identify what's the identifier for the workload,
correct.
and it gives you an MTLS certificate to that extent, but
Yes,
it doesn't tell you any of the claims. And when we say that agents are becoming first class identities, that means that they not only have identifiers, but they have certain claims. So
yes.
Spiffy doesn't say anything about what those claims are of the entity.
Yes, so there is, yes, SPIFFE is just only one part of the equation. There are, so when you register your agent, you're registering and saying, I'm going to use this LLM, I'm going to use this model, and I'm going to use this very specific model version. And then you're also specifying this is my AI bomb. So this is my supply chain version that I'm using, and then you're also saying I'm going to access a read for Salesforce, I'm going to do a read on Databricks or Snowflake, I'm going to do a write on your internal API for finance. So all of this registration will be done as part of the agent registration through Runtime AI.
Right.
Now we can monitor and do a runtime enforcement if one of your SBOM has changed, like upgraded
Right.
to
I
something.
understand the power of it. I'm actually just stuck on the registration part. So how does the agent register? Is that using any standard? And if so, which standard? Because saying we can use standards, well, the problem right now is that there's 50 standards out there.
Right.
And they're not standards, by the way. There's 50 drafts out there. And so I'm curious if you're seeing any one of these drafts getting particular adoption, and which draft are you using? If you say you're using standards, which I'm a developer, can I
Yes.
look at an OAuth draft and say, oh, they're using this type of agent registration from this IETF draft?
Yeah, so it's a combination of all of these, right? So when you create a registration, we create X509 certificate. So that is
Mm-hmm.
part of your existing OAuth 2.0, right? So you do DPoP, and then you do MTLS as part of that. Then we create a SPIFFE on our side, so you can do agent to agent identification. Then, as part of your registration, you send us all of these bombs, right? So that is also part of your ANS, agent naming service. So there is various standards that we are combining to create a unbreakable identity for the agents.
Okay, so it sounds to me like you're saying that in your view of the world, one AI agent equals one OAuth client.
Not necessarily. So it's what is basically your like destination where you are
Well,
creating.
DPoP is an OAuth standard, right? So
Yes,
if you're saying that we have an agent and it's using DPoP, it sounds to me like that agent is an OAuth client.
yes, it is underlying is what, right? So you are proving that you hold the key to that
Mhm.
identity, but that doesn't necessarily mean you are allowed to do 1,000, 10,000 reads to Salesforce in less
Yeah,
than a minute.
I'm still on the registration part. I'm not on the authorization part. I'm
Yes,
just so are you using OAuth dynamic client registration when you say
yes,
the agent registers?
exactly. We are. Yeah.
Okay, thank you. Now I understand what register means. So you're registering, and the agent that's registering is using a SPIFFE identifier, or is
We
generate
create
or
a
you,
SPI identifier on behalf of the agent inside.
So you're generating a SPIFFE identifier and returning that as the client ID.
Not returning, but we are storing that so we can identify when the traffic comes from that agent. We also create a hash of every identity the agent has, including X509, which models, which LLM, what version, what access permissions it's requesting. So if anything changes, so for example, you only had a read access and suddenly you are doing the right access, like right
Yeah,
calls. So your OAuth allows right, we stop because you only initially registered to Runtime AI that you are going to read. Now, why are you doing writes?
I see. And in terms of client credentials, um, the agent is using asymmetric authentication.
Yeah.
And where is the agent storing the private key, or is that out of scope for you?
No, no. So we secure the agent environment as well. So they are so when you store, you're storing inside a vault, a quantum post quantum safe vault that Runtime AI has developed, and all of your memory and all of your context is stored inside a quantum vault. So even if your agentic environment is breached, all they get is bunch of encrypted information, which doesn't mean to anybody outside of Runtime AI. So the private key is stored in one of those vaults.
Yeah. Um, you mentioned, okay, so now I think I understand the agent registration piece and the governance piece. So you're registering agents using OAuth. Um, you're keeping control of the resources away from the agents.
Yes.
Um, and then you're governing risk based upon anomaly, detection and other things. Um, and let's talk a little bit about the policies, because you mentioned you're using OPA for policies.
Yes.
Um, but in OPA, in Rego is a programming language.
Yes.
So um, is the idea that you're generating Rego code for the client? Or is AI writing, taking the human input and then writing Rego policies? Um, and then are those Rego policies then reviewed by anybody? Because the idea that software is writing Rego policies, that sounds very productive to me, but
Yes.
also potentially um, like error prone. Like I don't trust. Like I like the productivity of Claude writing Rego for me, but I don't trust it a whit to actually get it right because um, Claude will be like, "Oh yeah, here's your code," and then you'll say, "Why is it wrong?" And it'll say, "Good question, Mike. You're right. It is wrong. Here's why, and let me
Yeah.
fix it." So how do you sort of make sure that that English language like thing that we said actually gets implemented in code, and we can prove that that's right?
Yes. So yeah, there are three ways we generate the policies. When you install Runtime AI, it comes with our predefined policies for certain risk and what agents you want to allow. We also do agent lifecycle management. As agents are created, agent bombs are updated, agent access is updated, agent is deleted, what actions you want to take. This is through autonomous operations. So the natural, we have a parser and we have an API where you can validate the regos. So let's say you are saving all of your policy in a CI/CD, which you should be, and
Mhm.
you can promote that policy to production. And once you promote to our control plane, it sends all of the policies to enforcement points in the data plane. So before you promote, you would call our API to validate, and it's a simple compiler, right? And same thing when before we accept a policy through the API, we also compile and make sure it compiles and it can be parsed and sent. It's the right language. It can send across. So, but this is all hidden because we can allow you to do a English natural language expression, and we generate a right policy language, and then it is already compiled. and made sure it can be enforced. And the second part to this is we also run an AI agent. This is like advanced use case. We are looking at your entire landscape of AI agents, what they are accessing, destinations, and we automatically suggest you policy, and you can accept that policy to update your infrastructure. For example, a developer suddenly created another 5 different agents that are accessing different destinations in AWS or GCP. We can create some policy and suggest that, hey, you should be adding these policies to govern these new agents, and you can accept that and it will be added to the runtime enforcement.
So we're running out of time, actually. The pigeons are flying and telling us we're almost done. I have one hot seat question for you, and then we'll go to last thoughts. Um, you're knee deep in the AI space, and I wanted to ask you, just at a high level, like maybe 15-second answer, do you think MCP has become essential infrastructure like AI, or is MCP a flash in the pan that's just like a fad that's going to go away?
It's a great question. I posted one article wherein there are certain CVE vulnerabilities with the MCP protocol itself, and Anthropic being the architect of MCP, they said they will not be fixing this. This is like existing behavior. That means the onus of securing your MCP servers, MCP communication, is now on to the developers and the enterprises. So that's where like Runtime AI comes in and provides security and governance for MCP tools. And MCP also adds in a lot of token usage to you, and people are like slightly aware that okay, MCP is just a API gateway to existing APIs. I can just go call existing APIs through my AI agents. So that's where now runtime enforcement, runtime AI becomes more important, because whether you use MCP tools or APIs or LLM APIs or inference APIs, we sit in between your agents and the destination, and we can secure whether the destination is MCP or internal APIs or external B2B APIs.
Okay, so let's go to last thoughts. Just to give you a chance, this is just a quick conversation. Any other summaries from today, conferences you'll be attending, or any other last thoughts before we call it?
Yeah, few things is yes. So we are not replacing your identity layer. We're not replacing your network security layer. We are adding a runtime enforcement layer because of the new attack surfaces that are brought out by AI. So every call, every identity has to be verified at runtime, inline, cryptographically grounded, and you have to have a platform that provides you identity, granular access, policy enforcement, security, and compliance in single place. You don't need to accumulate 10 to 15 different vendor solutions, build it all yourself, whereas use one product, one company, and one platform, you get entire end-to-end security for your AI agents accessing your destinations.
Nice, makes sense to me. Um, okay, quick notes. There's episode notes up on GitHub Wiki, glue.co IOH-202, which is the episode number. And yet another quick reminder to follow the live stream on LinkedIn or YouTube. And just want to announce the next episode will be Steve Tout. We solved identity, then we hired agents. So more conversation on agents next week. Um, and with that, Roshan, I just want to say great conversation. I learned a couple of things for sure. So thanks for being on the show.
Thank you, Mike, and happy to be here. Yes.
Great. And thanks, audience. And we'll see you next time.